For the fourth video, we're going to actually talk about how to solve absolute value equations and inequalities. If you skipped straight to this video and you didn't see equation number 3, stop, go watch equation number 3. Because you really aren't going to understand what's going on here without doing that. A lot of the time, I see students just go straight from absolute value of x minus 7 equals 5 straight to x minus 7 equals 5. And that's not the only solution. That's not quite how we interpret what's happening here. There's an absolute value thing. We have to account for that fact. We have to deal with that fact. So go watch video 3 if you haven't yet. And if you have, then we'll go ahead and follow along. We'll talk about what this means, because you already kind of know. It doesn't matter what's inside those absolute value things. It could be x minus 7, it could be just an x, it could be a 2x plus 17, y minus 32, whatever. It doesn't matter. Remember that an absolute value is a distance. So that means that on a number line, what we're saying is that whatever is inside those bars is either at -5 or at +5, because the absolute value is a distance from 0. And if this thing is 5 units from 0, that means it is either here at +5, yes, or at -5. And that's exactly how we then interpret this equation. We split it into two different things. Either x minus 7 is equal to -5, or x minus 7 is equal to +5. And now we just have two equations that we solve. Plus 7 over here, plus 7 over here. I get x equals 2, or add 7 to both sides to this one, and I get x equals 12. And that's it. That's my answer. I'm saying that there's two answers. That's almost always the case. When we have an absolute value equation, we're almost always going to get two answers, because we could be at either of these two places on the number line. And I can't say that they're both, I'm not going to say and. That's an important bit. I can't say and here. It has to be or, because x can't equal 2 and 12 at the same time. You could say the solutions are 2 and 12, that's okay. But it might be better to just go with this, since that's probably where you're going to end up. Just make sure that you include that or. Alright, that was a fairly straightforward problem. The next one, the last one here that you'll notice, is a bit more involved, because not only is it an inequality, but we also have stuff beyond the absolute value. This is the important bit. This absolute value, think of this as a box. And we can't touch what's inside the box. We're not allowed. In fact, we're really not even allowed to look at it. Because what's going on inside the box has no importance to the inequality as a whole until we get that whole thing isolated. So pretend that just is one variable. We'll call it a. And instead, we have 2a minus 3 is greater than or equal to 7. It doesn't matter what's inside the absolute value inequality. We have to isolate the absolute value first. Before we can do anything else, we have to isolate the absolute value. And so I'm going to treat this like it was a regular equation. I'm going to add the 3. I get 2a is greater than or equal to 10. You don't need to actually do this. I'm doing this for illustrative purposes. You don't actually have to replace it with an a. If you leave it as vertical bars, absolute value, x plus 1, that's fine. You don't actually have to replace it with an a, but it might be a good idea to if you're tempted to like start distributing or something like that, or combining like terms. We can't do that. These aren't parentheses. They kind of work like them, but they're not exactly the same. We can't distribute. They're not distributable parentheses. And you could argue that they are, but then we get into weird circumstances of whether that's a -2 and then we're putting a negative inside vertical bars, and just don't do it. It's really what it comes down to. Leave the vertical bars alone. Leave the absolute value expression by itself. and isolate it. So we have a is greater than or equal to 5. So a was x plus 4, so I'm going to put that back in. And if you had never taken it out in the first place, then that's fine. Absolute value, x plus 1 is greater than 5. Now, from the previous video, again, you should remember that this means that wherever we are, whatever x plus 1 actually is, that means it's either at 5 or negative 5, because it is greater than or equal to, or beyond. So we have, this is the general picture. But this would just be of x is greater than or equal to 5, not x plus 1. So we can kind of take that same idea, though. We can either say that x plus 1 is greater than or equal to 5, or x plus 1 is less than or equal to negative 5, because it's either to the left of negative 5, or including the negative 5, or to the right of positive 5, or including positive 5. And now again, we just have a simple straightforward thing. Minus 1 from both sides here. I get that x is greater than or equal to 4. Minus 1 from both sides here. I have x is less than or equal to negative 6. And again, I have to say or, because these things can't both be true. So when I graph them on a number line, since that was the instructions, don't forget to graph, that the instructions say to graph. Negative 7, negative 6 there, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. And I have a solid filled in circle at the negative 6, because it's including. Arrow to the left, because it's less than. And a solid filled in circle at the 4, because it's greater than or equal to. And an arrow to the right. And that's my solution. That's my graph. And I'm done.